The Australian bushfire crisis in the summer of 2020 has been highly traumatic. Thousands have lost their homes or jobs, with at least 30 people dead. As a resident of Sydney, Australia, the discussion and explanation is obviously both topical. This presentation holds its reason for existence, Kirk's 2012, obviously in the course requirements of what we are asked to do. But why we are doing it is in part due to the very topical and urgent nature of the crisis. And we are doing it for people who do not realise the impact of climate change around the world. Our intention, through a selection of explanatory, exploration and exhibition visualizations, is to educate and motivate the viewers to understand that action towards climate change is required, and that by understanding the facts, they may be spurred on to make a change in their life or behaviour that may lead to a better world for us all. As a team of 4, we have had to select from the 8 hats of data visualization, Kirk 2012, and the best team that would optimize our collective output. We have selected the roles of broker, the identifier of audience and tone for the visualizations, project manager, the overall manager and motivator for the project, maintaining timelines and intentions, data scientist, the principal visualization technical skill in the team, responsible for the majority of the visualizations presented, and the technologist, the identifier of technological distribution and engagement by the audience, the web developer. The first type of chart we choose is the line chart. Through this chart we show the audience the overall bushfire condition in Australia from October 19 to January 20. The x-axis is time and the y-axis is the number of fires. The audience can compare a continuous quantitative variable on the x-axis and the size of values on the y-axis. We set the spacing between points to 1 week, which makes the data region show a noticeable change and does not make the data region too complicated. We also use line charts to represent the mean max temperature per day by year for 3 cities in the past century, and Melbourne is one of them. An important reason we choose line charts is that unlike bar charts, the y-axis of a line chart does not need to start from 0 because we are viewing the relative pattern of the data journey. The second type of chart we choose is the scatter plot. In this graph we show the change in CO2 emissions per person in Australia over the past 2 decades. Due to the dense arrangements of dots, we can easily see how the value has changed even if the dots are not connected. So we don't connect the dots to make the data region more concise. It can be seen that from around 2007, CO2 emissions begin to decline steadily. We had a marker here to associate this turning point with a historical event. In December 2007, former Australian Prime Minister Kevin Rudd officially signed the Kyoto Protocol, which restricts CO2 emissions. According to the Australian government, Australia outperformed its first target under the Kyoto Protocol. Our direct action plan on climate change has us on track to meet our commitments to reduce emissions by 5% below 2000 levels by 2020, which is equivalent to 13% below 2005 levels. It can be seen that from about 2007, Australia's CO2 emissions were in good control. The third type of chart we choose is the dot plot map. The purpose of this chart is to show the distribution and change of fire in Australia over time. The legend on the right is the meaning of the colour. The darker the colour, the brighter the fire detected by the satellite. In order not to convey misleading information to our audience and cause panic, we did not deliberately enlarge the area of the fire to make it more visible. However, in order to make the less bright fires visible to the audience, we adjusted the map color to dark to increase the resolution of the data region. In addition, we have marked the locations of some important cities on the map to help the audience grasp the site and size of the fire. We set of this GIF. There are constantly changing dates in the bottom left corner, allowing viewers to watch the changes in distribution of the fire from October the 1st, 2019 to January the 11th, 2020. We did not put all the fires detected by satellite on the same static map because they may make the audience mistakenly believe that these fires occurred simultaneously. Through the dynamic map, we can help the audience grasp the real progress of the fire condition, at the same time compared with displaying a series of static maps that change over time. This way saves display space. What's more, in order to let the audience get important information in a short time, we framed the visualization in another map. We narrowed down the data region to New South Wales and Victoria on the east coast of Australia, which is the area that were most affected with this year, with many fires near important cities like Sydney and Canberra. That should have been on the last slide, but there you go. Right, so now, Data Analyst, week 2. I'm not going to read all of this. I need to break this down and present it in some way that makes it a bit more palatable or easy to digest. But I'll do that for you, Scott, because my God, man, you've done enough of the work on the visualizations, which are looking pretty good to me. So I'll piece this together in a nice, flashy way. But there's a nice bit of detail there, so all good. After getting the right results, the right data sets for this project and selecting the right charts for the project, we carefully picked some technologies and tools to help us bring the story to life. The decision on what technologies, tools, or platforms to use for this project was in two folds. The first one was selecting the tools or software to use for data cleaning and plotting charts. The most important requirements for any software or programming language is to be used here, where how fast it can clean or process large amounts of data, and how easy it is to use. The second decision to make concerned how and where to host the final visualization solution for our intended audience to have easy access. For cleaning our data sets and plotting the various charts, we used both R, RStudio, and Python with Jupyter Notebooks. R and Python make cleaning large volumes of data easy and straightforward. Some of our charts were in the form of GIFs, and using a Jupyter Notebook with some Python libraries was the most efficient way to achieve creating these GIFs. When the charts were ready, we built a website to showcase the entire solution. The website was built using simple HTML, CSS3 and JavaScript and hosted on the Firebase platform. With these languages and a free platform like Firebase, we had the full control over designing and presenting our solution. However, we wanted, depending on how we wanted the story to flow. The website is interactive, so visitors can swipe through the charts and read details about each of them. I recommend that you go to the website. The link will be in the top right hand corner, and investigate for yourself. Thank you for watching.